one typo on here that we will correct when we get to it. Having said that, number 1, find the slope of the secant line for y equals x cubed minus 2x squared plus x plus 3 from x equals 1 to 3. Let's see what we have. Y is equal to x cubed minus 2x squared plus x plus 3. And x is on the interval 1 to 3 inclusive. So, slope of the secant line is the same as the average rate of change, which is f of x2 minus f of x1 over x2 minus x1. In our particular case, that's going to be y evaluated at 3 minus y evaluated at 1. Man, lost my ability to write. We just wanted to see. Over 3 minus 1. Well, plugging in, 27 minus 18 is 9, plus 3 is 15. Plugging in 1 minus 2 is -1, plus 1 is 0, plus 3. And doing the arithmetic, 12 minus 2, 12 divided by 2 is 6. Okay. Now let's look at some limits. The limit as x approaches 2. As x approaches 2 of x squared minus 3x plus 2 or x minus 2. Anytime we're looking at a limit, often the first thing we try is direct substitution. Direct substitution, 4 minus 6 plus 2 is 0. 2 minus 2 is 0. We have form 0 over 0. Since these are polynomials, that means there is a common factor. X minus 2 times x minus 1 over x minus 2, looking for the limit as x approaches 2. Everywhere that x is not equal to 2, that number clearly divides that number. That is, that limit is 1. And then we just put, now we direct substitution, 2 minus 1 is 1. The first limit is 1. The second limit, we're charging toward negative infinity. Limit as x increases without bound in the negative direction of 3x minus 7 over x plus 2. 3x minus 7 over x plus 2. Just back to your pre-calculus or college algebra or high school algebra 2, that we have a rational function which will have a horizontal asymptote at a ratio of leading coefficients if they're the same degree. That's first degree, this is first degree. So this limit is 3. That is, if this were written as a function, y equals 3x minus 7 over x plus 2, it would have a horizontal asymptote at y equals 3. And this last limit as x increases without bound in the positive direction of x minus 2 over x squared plus 3x minus 10 and here both numerator and denominator applying without remorse. The denominator factors, does it? But how does it factor? X minus 2 over, let's see, it looks like x plus 5 times x minus 2. Sure enough, we look at it that way, divide those out, limit as x increases without bound. So basically we have 1 over a very large number, which is 0. But again, from college algebra or that level, when we have a rational expression, the limit as it increases without bound, if the degrees are the same, it goes to the ratio of the coefficients. If the numerator has higher degree than the denominator, it goes off to infinity, either in a positive or negative direction, depending on the signs. And if the degree of the denominator is greater than the degree of the numerator, it goes to 0. Okay. Number 3. We have a function. F of x is equal to x squared plus 4x minus 5, x squared plus 4x minus 5 over x plus 2. And we want to find the asymptotes the intercepts, and we want to sketch a reasonable shape. Okay, so we're looking for all those things. Let's start with the asymptotes. And we have vertical asymptote. When we have division by 0, and division by 0 occurs at x equals -2. In this particular rational expression, since the degree of the numerator is only 1 more than the degree of the denominator, we also have an oblique asymptote, or slant asymptote. Which we find simply by dividing the denominator into the numerator. X plus 2 divided into x squared plus 4x minus 5. X and x squared goes x times, multiply back, x squared plus 2x, subtract 2x, bring down the 5, -5. X into 2x goes plus 2 times, multiply back, 2x plus 4, subtract, -9. So this function also behaves like the line x plus 2 plus a little bit of remainder, and as x increases, becomes very large in the positive sense, that's effectively 0. As x becomes very large in the negative sense, that effectively becomes 0. So it says our oblique axis, our oblique asymptote is y equals x plus 2. Not because of that denominator, but because of this numerator. So we have the asymptotes. Now let's go for the intercepts. The y-intercept is when x equals 0. So by direct substitution, 0, 0, -5, 0, positive 2, -5 halves. That is the point 0, -5 halves. The x-intercepts are when y is equal to 0. Let's solve that here. 0 is equal to x squared plus 4x minus 5 over x plus 2. If we have, in this case, a rational expression, but it's a fraction, and the only way a fraction can be equal to 0 is if its numerator is equal to 0. Another way to get there is multiply both sides by the denominator, x plus 2. X plus 2 divides out. x plus 2 times 0 is 0, so first step. Now we have a quadratic. This quadratic factors, let's see, x plus 5 times x minus 1, which indicates that x equals -5 or x equals +1. That is, the x-intercepts are -5, 0 and +1, 0. So let's put a graph over here. 1, 2, 3, 4, 5, 6. 1, 2. Okay. Have vertical asymptote at -2. We have an oblique asymptote at y equals x plus 2. We have a y-intercept of -5/2. We have an x-intercept of -5 and +1. We can find some other ordered pairs. Pick x, find f of x. For instance, at x equals -1, 1 minus 4 minus 5 is -8. -1 plus 2 is 1. -8 divided by 1 is -8. So let's see. 3, 4, 5, 6, 7, 8. So I've had, there's x down there somewhere, or goes to that point. Let's check, I don't know, let's say 3 maybe. So just to pick points, this was -8. +3. 9 plus 12 is 21. Subtract 5 is 16. 3 and 2 is 5, 16/5. What's that? 3 and 1/5. At 3 we get 3 and 1/5 somewhere up there. On the other way, I might pick -3. -3, let's see, +9. -12 minus 5. What's that? +8. -3. Actually, that was -8. -3 down here gives -1, so we end up with a +8. 6, 7, 8 up there someplace. So if we kind of do these with a smooth curve through these points that we found, and otherwise we see it goes something like that. It is asymptotic, so eventually it gets close up there. But as pretty as that wonderful drawing is now, it's still totally incorrect. Still, we do a couple of things. We have to label the axes, and we have to indicate some kind of scale. So, once you have a scale, once you have your axes labeled, and then you can smooth in the curve. Also, if you put this on your TI-89, you'll see that its shape is verified. Be sure when you enter it on your TI-89, it's diamond y equals, then put paren x squared plus 4x subtract 5 close paren divided by paren x plus 2. Because you want the whole numerator divided by the whole denominator. So be sure to enter it correctly. And then pick an x window from about -6 to +6. Pick a y scale, all about the same. And you kind of get the see the shape of the curve. Okay. Number 4. We want to use the definition, even though we could easily find the derivative by rule. Here we want to use the definition. Oh, by the way, anybody else need a 3 of you at least? Well, let's walk that way. Hold on. Okay. So definition, given y equals f of x, dy dx is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h, where that limit exists. In our particular case, our function is f of x is equal to 4x cubed minus 7x plus 3. So, f prime of x is limit as h approaches 0 of 4 times x plus h cubed minus 7 times x plus h plus 3. That is my function evaluate x plus h minus my function 4x cubed minus 7x plus 3, all divided by h. Doing the arithmetic in the numerator or the algebra in the numerator, limit as h approaches 0 of 4x cubed plus 12x squared h plus 12x h squared plus 4h cubed minus 7x minus 7h plus 3 minus 4x squared, 4x cubed plus 7x minus 3, all that divided by h. Like terms, positive 4x cubed and its opposite negative 4x cubed added out. Negative 7x and positive 7x opposites add out. Positive 3 and negative 3 add out, equals, factoring in h as I go, limit as h goes to 0 of h times 12x squared plus 12xh plus 4h squared minus 7h over h. These h's have a limit of 1 or divide out. And now we can let h go on to 0. Which means that term goes to 0, that term goes to 0. Oh, forgot to factor that h. My apologies. Factoring in h is just 7. Leaving 12x squared minus 7.
How strict are you on having the limit as h approaches 0? Have to have it on every step except for that last one?
Well, think of it as writing sentences in English. You start every sentence with a capital letter. Every time you leave off a capital letter in your theme, what does the English teacher do? They take off points. It's syntax. As long as you're seeking the limit, use the limit notation. When you conclude, there's no limit notation because that is, you've reached your conclusion. But here we've not reached our conclusion yet, nor here, so we use the limit notation.
Say you forget one in the middle, like that's points off.
That'd probably be a point off, but still. I got an A- on theme when I had a spelling error in the title. What was Genghis Khan? How do you spell Genghis? Yeah, exactly. That's having said that, I was real happy to get the A- because my previous themes had B's and B minuses and 1 C. So happy to take my B in the course and get on down the road. Okay, now it gets real easy. We get to use the definition. The rules that we have developed for these. So let's write down a few of these rules. F of x, f prime of x. Let's begin with what we just used. F of x, f is over here. We want f prime of x is equal to limit as f of x plus h minus f of x over h as h goes to 0. There's our definition. But then we have a constant whose derivative is 0, a constant times a function whose derivative is the constant times derivative of the function, a sum of functions, f of x plus g of x. Derivative is the sum of the derivatives. Difference, f of x minus g of x is f prime of x minus g prime of x. Product, f of x times g of x gives me f prime of x, g of x, plus f of x, g prime of x. And quotient, f of x divided by g of x, with a caveat, g cannot be 0. There we get derivative of the numerator times denominator, subtract numerator times derivative of denominator, divided by the square of the denominator. Then we added a few more. We have the power rule, which works for all real numbers. They presented it in 2 steps. One step was n a positive integer, but then they said, well, it works for all real numbers, so we'll just write for all real numbers. Derivative of x to the r is r times x to the r minus 1. Then a function can be defined so that it is equal to its own derivative everywhere. That function turns out to be an exponential, e to the x. And we played around a little and said, oh, well, what if the base is not just e? What if it's some other base? And if it's some other base, we do get the exponential back, but we also get the natural logarithm of the base. We will do this again after the test. I don't think I have one on the test that uses that one yet, but I have it listed. And then we did the trigonometric functions. So, derivative of the sine of x is the cosine of x. Derivative of the cosine of x is minus the sine of x. The derivative of the tangent of x is the secant squared of x. Derivative of the cotangent of x is minus the cosecant squared of x. The derivative of the secant of x is the secant of x times the tangent of x. And derivative of the cosecant of x is minus the cosecant of x times the cotangent of x. So there's our list of rules. Aren't too many of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 that we will use. Okay. So the first one is a rational function. R of x is x squared minus 5x plus 3 divided by 2x cubed minus 7x squared plus 1. So R prime of x is quotient rule. Derivative of the numerator 2x minus 5 times denominator 2x cubed minus 7x squared plus 1. Subtract numerator x squared minus 5x plus 3 times derivative of denominator 6x squared minus 14x, all divided by 2x cubed minus 7x squared plus 1, quantity squared. If you get to here, you have demonstrated that you know how to take the derivative. If you punish me by going on and multiplying all that out, getting a 4th degree polynomial in the numerator and a 6th degree polynomial in the denominator, you're welcome to do that. But just keep in mind, the more steps that you take, you increase the probability of some kind of error.
So you'll accept just the setup?
That's it.
Yes, sir.
Yeah. And you know, if it's real easy, if it said 3x minus 4x, yeah, do that. But, I mean, you know, as much as I like algebra, and I know you do too, this test is about derivatives. You can demonstrate some other time how bad you are at algebra. Number 6. G of x is equal to a couple of products, 3 sine x tangent x, 3 times the sine of x times the tangent of x, subtract twice the cosine of x times the cotangent of x. Okay. There we go. The first product, 3, derivative of the first factor cosine x times second factor tangent x plus first factor 3 sine x times derivative of tangent of x, which is secant squared of x. Subtract 2 times derivative of cosine, oh, that's minus the sine, so I'll change the sign there, times cotangent of x. Subtract 2 times cosine x times derivative of cotangent, but derivative of cotangent is minus the cosecant square of x. So you end up with 4 terms in the derivative. Number 7. F of x is e to the x secant of x. E to the x secant of x. Oop. Secant of x. Well, let's see. F prime of x is product, so it's derivative of the first factor, e to the x, times the second factor, secant of x, plus first factor, e to the x, times derivative of the second factor. Derivative of the secant is secant of x, tangent of x. Yes, you could leave it like that, but this one is easy enough also to factor. E to the x, secant x is in both terms 1 plus tangent x. Would be one way to simplify that. And if you do that top line, that's good. Okay. Now here we go. Write the equation of the tangent line to the function f of x equals a product 3x squared minus 4x plus 1, 3x squared minus 4x plus 1 times x cubed minus 7 at 2, 5. But sometimes I've been known, yes.
You can do number 8.
Oh, and that's a fun one. Okay. I don't want to erase that, so I'll erase something down in the center. But not the rules. Number 8, I'm told I skipped. G of x. Oh, by the way, having said that, just because problems are presented on a test in a particular order doesn't mean that you have to work them in that order. Because it is to your advantage to kind of scrutinize the test before you actually begin and say, which ones do I know are rock solid? And do the ones you know how to do rock solid, and then start worrying about the others. That way you don't get to number 2 and say, number 2, what do you mean by number 2? Is that the number that comes after 1 right before? And spend 45 minutes on number 2, realizing now you're very short on time to do all the other problems. Okay. So, number 8. 3 cosecant x times sine x. 3 cosecant x times the sine of x plus square root x over 4 e to the x. Plus square root of x over 4 e to the x. Okay, here we go. G prime of x. We have a product. Derivative of the cosecant is minus 3 cosecant x cotangent x times sine x plus 3 times cosecant x times sine of x is cosine of x. Okay. I took care of that. Plus quotient rule. This is x to the 1/2. So its derivative is 1/2 x to the minus 1/2, or 1 over 2 times square root x. So derivative of the numerator, 1 over 2 times square root x times the denominator, 4 e to the x, minus numerator, square root x times derivative denominator 4e to the x divided by the square of the denominator 16e to the 2x. Whew. And yes, that can be simplified a little bit. Clearly, this is 2, that's 4, that's 16. Divide by 2 and make it a little nicer. Could multiply through by square root x over square root x and get rid of a couple of these, but put a square root down there. But you know, you can play with that. But here's what I want you to notice. All that was 0. How could it all be 0? What is the cosecant of x? How's it defined? 1 over sine. What is 1 over sine times a sine? What is 1 over 17 times 17? What is 1 over 11/6 times 11/6? 1. What is 3 times 1? 3. What is the derivative of a constant? 0. So, if you recognized your trigonometric identities, all of this didn't have to be done. Now you can check this too. Let's see what we have here. 1 over sine, sine. Go away. I have minus 3 cotangent x. Over here, somewhere I lost it. 3 cosecant minus cotangent sine x, 3 cosecant x, cosine x. Okay. And here I have plus 3. Oh, right there. Oh, sine x. Anyway, if you check that, it ought to add out somehow. Oh, I added out the wrong things. Okay. If I factor the cosecant and the 3, I have 3 times what's left minus cotangent x sine x plus cosine x. Cotangent is cosine x over sine x. Sines divide. I have minus cosine plus cosine. 3 times minus cosine x plus cosine x. So, you either do all that work or recognize that this is 1. That makes the derivative a little bit easier. Okay. Back to number 9. Write the equation of the tangent line. We had a secant line earlier, but now we're looking for a tangent line. And the slope of the tangent line is the derivative of this, evaluated at x equals 2. The question is, does this point belong on that line? Let's see. If x is 2, 12 minus 8 is 4, plus 1 is 5. 8 minus 7 is 1. 5 times 1 is 5. So 2, 5 is the point on the curve, so I didn't make a mistake there. So let's find the derivative. F prime of x is derivative of the first factor, 6x minus 4, times the second factor, x cubed minus 7, plus the first factor, 3x squared minus 4x plus 1, times the derivative of the second factor, 3x squared. And in particular, I want to know the value of the slope at 2. Let's see. 12 minus 4 is 8. 8 minus 7 is 1. 12 minus 8 is 4, plus 1 is 5. 12. This is equal to what, 68? F prime at 2 is equal to 68. So we have a point and a slope. Remember the point slope formula line, y equals the slope times x minus x1 plus y1. In our case, y equals 68 times x minus 2 plus 5. Or y equals 68x minus 136 plus 5 is minus 131. Equation of the tangent line at the point 2,5. It's not quite straight up, but it's pretty steep. I wish my money would grow at that rate. Nah, that'd just be greedy. Okay. And number 10. Given f of x equals twice the sine of x, and g of x equals cosine of x, find all points on the interval from 0 to 2 pi where f prime of x equals twice g prime of x. We start with f of x and g of x. Let's see, f of x is twice the sine of x. G of x is the cosine of x. Derivatives. F prime of x is twice the cosine of x. G prime of x is negative sine of x. And it says find where f prime of x equals twice g prime of x. So let's write this equation. F prime of x equals twice g prime of x. That is f prime 2 cosine x is equal to twice minus sine of x if I divide by let's divide by 2 cosine of x equals minus sine of x. Divide by sine of x which means cotangent of x, negative 1, perhaps the function you're more familiar with, tangent of x is the reciprocal of cotangent. What's the reciprocal of negative 1? It's also negative 1. So we have that. I say to myself, self, how do we solve that? Oh, that's one of those exact values that you should remember from trigonometry. But if you don't remember from trigonometry, let me draw a unit circle up here. This is pi over 4 for 45 degrees. tangent of 45 degrees is 1. So this is 3 pi over 4, 5 pi over 4, 7 pi over 4. So where is the tangent equal to -1? The tangent is the y value over the x value, positive 1. The y value positive over the x value negative, -1. Negative over negative, positive 1. Negative over positive, -1. Or you can write x as element of the set, 3 pi over 4, comma, 7 pi. Couple of ways to express your answer. If you write down the answers 135 degrees and 315 degrees, technically you're correct. However, that's like saying measure this to be 60 inches long, ask you to express that in feet, and you say 1 yard, 2 feet. Technically it's correct, but it's not the proper units. So if you answered in degrees instead of radians, got to take off a point or two. Not a major disaster, but you know, if you lose a point on every question, your maximum score you can make is 90%. If you make other mistakes besides those piddling ones, then your score's not scores. Okay, where are we? Number 11 is the one that has the typo. Given S equals S naught plus V naught T how do you spell omission? 1M or 2? Plus 1/2 AT squared. Okay. I left the T out on V naught, so let me change that word omission to insert. It's still workable if V naught doesn't have a T, because then that's just another constant, but not what I intended. Okay, and it tells me that S naught is 1.82 meters. V naught 4.9 meters per second squared, or per second, excuse me. And A is equal to -9.8 meters per second squared. Okay. So that's the given information. It says find S and V at t equals 4. So S at 4 is 1.82 plus 4.9 times 4 minus 4.9 times 4 squared. Let's see. 1 1.82 plus 4 times 4.9 minus 4.9 times 16 is negative 56.98. That's not what I got this morning when I did it by hand. Hopefully they'll find my arithmetic. Did I key it in right? 1.82 plus 4 times 4.9.
Should be minus 9.8, okay. Am I?
Yes. A is 9.8. But half of it is only 4.9. But thank you for pointing that out, because several of your peers were also saying, where that 4.9 came from? That's where it came from. I recognize my 1/2. So, if I punch the keys correctly, it looked like it is. Let's clear this by the skin. 1.82 times, not times, plus 4.9 times 4 minus 16 times 4.9. Yeah, I'll say negative 56.98. Negative 56.98. Okay. So if that's horizontal, it's going backwards. On the other hand, if that's something that's falling under the acceleration of gravity, which it appears to be because that's what negative 9.8 is, then it's now falling, it has fallen from its starting point almost 57 feet downward. Okay. Next up, V is V naught plus T. V at 4 is 4.9. Oh, made a mistake here. Meters. 4.9 plus negative 0.98 times 4 is what, negative 34.3? Did I do that right? Meters per second. Again, since these involve units, units are important. So you omit the units and you crash and burn. Okay. Okay. Still along the same thing. It says find the range on level ground of a projectile fired at 900 feet per second at an angle of 40 degrees above horizontal with G, the acceleration of gravity, of negative 32 feet per second squared. Let's draw a picture on this next board. So, level ground, firing at about 40 degrees. It's 900 feet per second. And it goes out here someplace and crashes back to that same point some distance away. Okay, since it's level ground, we can assign the Y value anything we want. What's a pretty easy number to work with? So Y is 0 here, and Y is 0 here. And we're looking for range, so once again, one of these points is arbitrary. So what do you want to pick for X on this first point? Yeah, that's a good choice. So we're starting at 0, 0, and we're going to end up at some x0, and our problem is to find x. Okay? You've all seen that horrible math joke. And the question is find x, and the student says it's here. X is there. How do we get there? We solve two equations. We have a y position equation. Y equals y naught plus v sub yt, and in our case, minus 16t squared. Again, half of g. And we have another equation, x equals x naught plus v sub xt, and the acceleration, disregarding air resistance, is 0. With air resistance, acceleration is negative. Okay. After the initial boom. 'Cause, none of you can throw that fast, can you? Okay. And we have these values to put in. 0, 0. But we have some values here. We have an up component, horizontal component. The up component is 900 times the sine 40 degrees. Horizontal component is, and that'll be in feet per second, by the way. And the horizontal component is 900 times the cosine of 40 degrees, feet per second. So we use the vertical, since it has everything there, to solve time with. This equation is, the final y position is 0, the initial y position is 0, plus the initial vertical velocity, 900 times the sine of 40 degrees, minus 16t, I forgot, t, no, that's the velocity, times t. Hey. So basically we have 0 is equal to 900 sine 40 degrees times t minus 16t squared. We want to solve for t. This thing factors. 0 is equal to t times 900 sine 40 minus 16t. So either t is equal to 0 or t is equal to 900 sine 40 degrees divided by 16. Is it 0 times 0? And it's here sometime later. Let's do that arithmetic. This is in degrees, so make sure your calculator's in degrees if you punch this out on a calculator. But here, anybody know the exact value of sine 40 degrees? Oh, by the way, there is not an exact value for sine 40 degrees. It is a transcendental irrational number. So the best we can do is approximate it. 900 times the sine of 40 closed divided by 16 is about 36.15680304449 seconds. let's use this time and put it into this equation. X is equal to x naught plus v sub x, which is 900 times the cosine of 40 degrees times time. 900 sine 40 degrees over 16. So really, you don't have to punch this out because it doesn't ask how long it took. It says how far is that range. So I'm going to throw this in. 900 squared times the cosine of 40 times the sine of 40 divided by 16. I think I have all my numbers in there. And it tells me x is 24,927.9462. 481. Now, before you give me an answer like that, think about the application of the problem. You know, can we really predict where a projectile will land to the nearest 10th, 100,000, 10,000, 100th, millionth, 10 millionth? Can we find the position of that projectile to the nearest 10 millionth with all the factors that we have kind of just tossed aside? No. So it's ridiculous to do that. So if you give it to the, that'd be 24,928 if you do it to the nearest foot. Okay. And that's probably wrong too, because realistically, anything traveling at 900 feet per second initially will slow down significantly due to air resistance and land somewhat shorter. Okay. Having said that, any of you familiar with handguns, pistols? What's the common muzzle velocity of pistols? Around 900 feet per second. So, if you're goofing off out in the pasture with your handgun and you just go bang, just for fun, some innocent person almost 5 miles away, 4.72, can be lethally injured due to your fun and frolic and saying, happy birthday, bang. And then about a little over half a minute later, some innocent guy walking around, thunk. So, gun safety is important. And I've never met a gun that fires itself.
Do you guys do that by hand?
Well, you know, now the artillery is all automated. I mean, you know, it's all GPS coordinates. The guns all pretty much aim themselves. We had charts that we laid out things on, and we could calculate ranges and whatnot using a set of equations and whatnot. And it was kind of painful. We had a computer. And let me explain it. It's called FADAC. And this thing was about 2.5 feet square by about 15 inches deep. And you had to have a generator connected to it to make it run. And it could not, it had about the power of your standard cell phone on non-scientific calculator. I mean, it just. But the test that you took to show that you knew how to answer all the questions correctly on how to enter the data, the answers were multiple guess. 5 questions, choice A, or choice F, choice A, choice, what's next? D, choice A, choice C. You know, kind of scares me that there are artillery officers going out of their training knowing that the answers were the acronym Field Artillery, get this thing, Digital Analog Computer. I mean, I have seen watches that have a analog and then a little box in there that shows digital. So I guess you can have a digital analog something, but that's no longer in use, needless to say. Because that was the early 70s, and in the early 70s, calculators were almost non-existent and were very expensive. And a computer, the first computer I did any work on at the University of Oklahoma in the summer of 1961, was an IBM computer. It still had vacuum tubes. And the computer itself would fill up about half this room. And the other half of the room would have to be dedicated air conditioning. Because if you didn't keep the thing cool, the tubes would start exploding. And you'd write a program. And the university didn't own it. IBM, International Business Machine Corporation, owned it. So you would write your program in Fortran, type up a bunch of punch cards, a job control card, and you take your job deck in and hand it to a guy in a white lab coat. And then you disappear somewhere and feed those to the machine. And the next day you'd come get your printout. And those of you familiar with early Fortran, once you made a mistake anywhere in the program, basically all the rest of it's garbage. So maybe you get pages and pages of printout saying error, 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 tell you where error. So you just correct the first one, retype that card, hand it in again. My goal that summer was to hand in one program, get it right the first time. I did that on one program, but it was, weird, simple stuff like that. Computers have improved a little, just a little.